My name is Vijay Ramesh. My topic is Fundamentals of Generative Adversarial Network. Introduction. Generative Adversarial Network are powerful class of machine learning models introduced by Alan Goodfellow in 2014. GANs have revolutionized various fields such as computer vision, natural language processing, and even art generation due to their ability to generate highly realistic data such as images, audio, and video. The main idea behind GANs is to train two neutral networks in opposition to each other, leading to the creation of realistic data by the generator. What's GANs? Generative Adversarial Network. These are a type of unsupervised learning model consists of two main components. There are generator and the discriminator. Generator. The generator network is responsible for creating data that resembles the real data distribution. Its goal is to generate data that is distinguishable from the real data. Discriminator. The discriminator network task is to differentiate between real data from the training dataset and fake data produced by the generator. The discriminator assigns a probability that the input data is real. These two networks are trained simultaneously, and their goal is to improve iteratively, leading to the generation of realistic data. How do GANs work? The process behind GANs can be described as a minimum max game. The generator aims to fool the discriminator by generating data that is indistinguishable from real data. The discriminator aims to correctly identify whether data is real or generated by the generator. The generator and the discriminator are trained the following way. First one is generator's objectives. The generator's goal is produce synthetic data that is as similar as possible to real data. Initially, the generated data is random and easily distinguishable from real data. Second one, discriminator's objectives. The discriminator evaluates the real and fake data and tries to classify them correctly as real or fake. The training process. The generator creates fake data based on random noise. The discriminator evaluates both the fake data from the generator and the real data from the dataset and classifies them. The generator improves by receiving feedback from the discriminator, aiming to create data that is harder to classify as fake. This loop continues, with both networks improve over time. The role of generator and discriminator. Generator. Initially, the generator produces random noise as training progresses. It learns how to transform the noise into realistic data, improving its ability to deceive the discriminator. The discriminator is a binary classifier. It takes both the real data and the generated data and tries to predict whether the data is real or fake. Its performance improved as the generator creates better data. Together they create feedback loop. The discriminator helps the generator by providing feedback on how to improve the generated data. As the generator gets better, the discriminator also gets better, trying to keep up with the increasing quality of generated data. Key properties of GANs. Adversarial process. GANs are a type of adversarial learning where two networks compete with each other. The generator attempts to fool the discriminator and the discriminator attempts to detect fake data. Second one, unsupervised learning. GANs do not require labeled data. They learn from the underlying distribution of the data and can generate new data that resembles the training data. Third one is stochastic nature. GANs are inherently stochastic, that means random. The generator take random noise as input, which means that the output is varied, allowing the model to generate diverse outputs. Last one is mode collapse. A common problem in GANs is mode collapse, where the generator produces limited variations of data, failing to capture the full diversity of the training dataset. Applications of GANs. GANs have found numerous applications across different domains. First one is image generation. GANs can generate realistic image from random noise. One popular application is deepfake technology, which uses GANs to create realistic synthetic images and videos. Second one is art generation. GANs can generate art, painting, and visual designs that mimic the styles of famous artists. Third one is image super resolution. GANs can use it to enhance the resolution of low quality images, such as converting pixelated images to high quality versions. Next one is style transfer. GANs can combine the style of one image with the content of another, such as transferring the painting style of Van Gogh to a real photo. Next one is data argumentations. GANs can generate additionally synthetic data for training machines learning models, especially in cases where labeled data is limited. Next one is medical imaging. GANs have been applied in medical imaging to generate synthetic medical images, which helps in training models in data scarce environments. Thank you.